So hello guys, welcome to my YouTube channel again, and today we will be discussing the Leet Code Daily for 5th of February, and the question name is find all anagrams in the string. So this question is very similar to yesterday's problem, and for the yesterday's problem I have already made a video, so you can watch that if you want. So there I have discussed three approaches, and like the only difference between yesterday's problem and today's problem is that in yesterday's problem we were supposed to give true or false whether there exists any anagram or not. So the anagram is basically same as the permutation, right? Anagram is basically the permutation. So here also in anagrams also we have to check the frequency map of all the characters, whether for all the characters the character frequency is same or not. So it is exactly the same here. We just have to return the indexes of the starting point, and there we were just supposed to uh, give true or false. So today it will be a shorter video, so because like this is very similar to yesterday's problem, so if you want to understand in depth, go through that video. Okay, so yes, so like basically if you look at the first example, we were supposed to find this p string, and we have to find which substring of this are anagrams of this. So anagrams means that permutation of this. So you can see that ABC, and if you consider from the 0th index this CBA, it is basically same, right? The character count, there is 1A here, 1A here, 1B here, 1B here, 1C here, 1C here. And if you look at the 6th index also, 6th index is this BAC, this is also an anagram. So we have to return a vector containing the starting positions of all the substrings here, which are anagrams of this. So the brute force solution here will be the same, that you consider all the substrings here and iterate over all the substrings and check whether that substring of length 3, so whether that substring of length 3 is exactly the frequency count is exactly same as p, and if it is, then like put the starting point in the answer. So I'm not coding that up, but that is very simple. If you want to know the code of that, I will add in the description also, you can watch this. Here I have discussed the brute force solution as well. Okay, so the second approach, basically we have to check for all substrings of size 3. So if you want to check for all substrings of size 3, we can directly apply fixed length sliding window technique. Okay, so I will be coding that fixed length sliding window technique. So this fixed length sliding window technique is same as the second solution here, so I'll be directly coding that solution. Okay, so let us code this. So there I took map, here I will take a frequency array. Okay, so that both solutions are different and you learn different things. So first I'll find, so S is a bigger string and P is the smaller string. So for P, let us find what is the length of P. So int len is equal to P dot size. This is the length of P. Then I'll make one frequency array. The frequency array will be of size 26, as it is guaranteed that there are always lowercase English letters. So frequency of size 26, and I'll initialize them all with zeros. So 0 index will signify for character A, 1 index will signify for character B, and so on. Okay, and like how to get from the A character to 0. So if you subtract A character from A, you will get 0. If you subtract, how to get from B to 1, if you subtract B from A, you will get basically 1, because the ASCII of B, if you subtract from A, this is nothing but yes, the ASCII, if you subtract, so the ASCII are one different, like first you have A, then you have B, so the difference between the ASCII between B and A is 1. So if you subtract the two, you will get 1. Okay, so this is how we will get from A to 0 and from B to 1. Similarly for Z, we will have 25. Okay, so if you subtract from Z, if you subtract A, you will directly get 25. So this is how we are mapping. So for int I is equal to, or you can use a auto loop also for auto x in p. Then we have to find the index idx is equal to x minus a. Or it is better, if you don't understand it like this, you can use a for loop also. Okay, for int I is equal to 0, I less than length I plus plus idx is equal to p of I minus a. So this is the index, so that character minus a, this will give me the index. Like for a it will give me 0, for b it will give me 1, and so on. So I will increase the frequency of that idx plus plus. Then we are using that prefix sum, then we are using that sliding window technique here. So then we iterate over the first window, so then we iterate from the first window. So if you look at the first window, so first window in this s, so first find the size of this s. Then one edge case, that if s dot size is lesser than p dot size, then you will definitely not get any answer. So we'll have like this is our vector answer, vector int answer. This stores all the indexes, so you directly return answer here. Basically it is empty. Yes. So now we will iterate over all the windows. So for int, we'll iterate over the first window. So first window will be till length I plus plus, and yes, int idx is equal to, now we are supposed to take out this from s. Okay, so we'll create one more frequency substring, frequency of that substring of size 26, and initialize that to 0 as well. Then after that for I is equal to 0, this is the first window. So the first, the window size is length. Okay, so the window size, what is the window size? The window size is equal to len. So we'll iterate from that, and we'll take out this character, and we'll increase this in the frequency of substring of idx plus plus. Now we'll check whether this first substring is valid or not. So first window is valid or not. So this we have to check. This is the general fixed length sliding window technique. We first iterate over the first window, check for the first window, then iterate over subsequent windows, make the changes, and then check for that all the windows. Okay, so we have to check for all the characters. So I is equal to, so for j is equal to 0, j less than 26, and j plus plus. Okay, I'll make one variable is valid equal to 1. Initially I'm considering it is valid. As soon as we get some invalid character, then we'll mark it as invalid. So if frequency of I is not equal to frequency sub of I of j, sorry, here it should be j, here also j. If it is not equal, then that will mean that we have found one character whose frequency is different in both frequency and in frequency sub. So we'll mark is valid is equal to 0. So is valid is equal to 0, and we can directly break out like it is not valid. But if is valid equal to 1, that means it is still valid. So we'll push this, push back this. We have to push back the starting index. Okay, so starting index for the first window will be 0. Then we iterate over the ending points. So I is equal to end, I less than equal to, so we have said, suppose there is a suppose let us take this 7 size, a b c d e f g. This is a 7 size, and we have to find whether I have got, okay, let us change this to CBA, and we have to find whether how many anagrams of ABC are possible. Okay, so if I do the indexing of this 0, 1, 2, 3, 4, 5, 6, so the last window will be this window. So for the last window, the starting character will be this. Starting character will be this 4. Okay, starting character will be 4. So 4 is nothing but 7. This length is 7 minus the length of this 7 minus 3. So we can iterate over start here. So start is equal like this will be start. So start will be 1. So because start equal to 0 we have already considered. So start equal to 0 was this string, this substring. So we will consider from start is equal to 1, and for the last window the start will be till length, still num minus length, because num is the length of the bigger string and len is the length of the smaller string. So this is the start is equal to 1, start. So these are the subsequent windows, and start represents the starting character of for that window, like starting position of that subsequent window. And end, we know that if 1 is the start and we have to take a size 3, so the end will be nothing but start plus length minus 1. So start plus 2, basically like 1 plus 2, if you do, you will go to 3. So this is the end. Okay, so int end is equal to nothing but start plus the window size minus 1, because both sides are inclusive, so we have to do minus 1. You like, if you want to derive at some formulas, it is better that to take some example and try to see whether that formula is working or not. So in that way it is better. Okay, so then what we do, we like how to move from first window to the second window. Take the end and remove the start minus 1. So how to take the end? So we'll increase the frequency sub of what is the end. Okay, so the end is nothing but s of end minus 0. So this is the mapping thing. We increase it and we remove the start minus 1. So frequency sub of s of start minus 1, this minus 0, because we have to map a to 0 and this, so this minus 2 minus 0 we are doing. So here we took one variable and did it like this, but you can do it in one line also. Okay, so this is the one liner. So now we have to check the same thing, whether this frequency map is same or not. So the same, like checking code remains the same. So here you just have to check whether the two frequency maps are same or not. So is valid is equal to 1, from j is equal to 0 to this, all of this remains the same. And here we will just insert start, because we have to insert all the starting positions, and then we directly return this answer vector. Okay, so this is it. Let us test. Size 53. Okay, let us check. Frequency sub s end minus 0. It is not minus 0, it is minus a. Sorry, minus a. Yes. Yes, so samples are passing and it is accepted also. Yes, so this is the second solution. Like brute force, I haven't told you the code, but like I have told you the logic. So try to do that and try to do this also. The time complexity of this, if you consider, this is a n loop. Okay, this is a n loop, and in every n loop we are running a loop of size 26. So if you consider the time complexity, the time complexity is nothing but O of n into 26. And if you consider the space complexity here, so the space complexity used here is nothing but we are using two arrays of size 26, so it is just O of 26. Okay, so this is the time and space complexity for this solution. Now there is one more solution. I will not take much time in explaining that. So in order to, what you can do is, if you want to remove this thing, if you want to remove this 26, what you can do, this we already discussed in this solution. So the third solution for the yesterday's logic is exactly, and like here I have attached timestamps also. So from 30 minutes I am starting the most optimized solution, so you can move to that respective solution. Okay, so if you want to remove this, that is also possible. What you can do, so just we have to check two maps right here, whether for every character like at every character the frequency in the two maps should be equal, and like it should be equal basically. So what we can do here is we'll maintain one variable equal count. This will store for how many, we all over we have 26 characters, so this will store for how many characters we have frequencies in both the maps same. So here if it is not same, then we'll so here we don't need this valid and invalid. If equal count will be 26, that is for every 26 character the frequency in both the frequency array is same, that will mean that it is valid. So if frequency is same, then we'll increase this count, equal count will increase, equal count plus plus, and if this equal count becomes equal to the 26, then we'll say that yes, we have all the character frequencies same. Okay, rest remains the same. This we don't have to do this. Instead we have to do here equal count equal to 26, then we'll insert. So now we'll check how to how the equal count will change when we take this end character and when we remove this end character, when we remove the start minus 1th character. So see, then we have to add basically for remove case, for this end is basically when we take them into account, right? So before we increase the frequency of this s end, what we have to do, suppose before increasing the frequency it was equal, suppose there was this character, suppose s end is nothing but your d. Okay, suppose s end is nothing but your d. So what you did is, like earlier before inserting in this frequency array, the frequency of d was 5, and in this frequency sub also it was 5. Okay, but now what you are doing, you are adding one more d. So after adding it will become what, after adding this will become 6. So from equal it is moving to not equal, so from equal it is moving to not equal. So if this is the case, then in the equal count, like in the equal count I would have increased 1 for this d, because in the previous window it is equal. So in the equal count there must be a contribution of this d, right, because it is equal. But now that contribution is ending, so then I have to check if frequency of this s end minus a, I am using one variable for that. Okay, end idx, I will say it is end idx is equal to this. So if frequency of end idx equal to frequency sub of end idx, then equal count will decrease basically. Earlier from equal we are moving to not equal, so the equal count will decrease. Now we take that into consideration, now we take the end index. But yes, there may be the case here also that suppose this is one scenario. Now suppose there might be a second scenario that earlier this frequency was 5 and in the frequency sub it was 4. So here it is not equal. So it is not equal, but now from not equal it is now we take this d into consideration. Okay, so from not equal it is moving to equal. So what will happen is, from not equal we are moving to equal. So from this 5 4 it will go to 5 5. So now from this, now the equal count has increased for this d. So now we have to check that if frequency of end idx equal to frequency sub of end idx, then what you will do, then equal count will increase. Fine. So this is that we have to take care before adding that and after adding that. We have to take this into consideration. Similarly here also, before removing the start minus 1th index, okay, you have to take that. So start idx, I am storing this in one variable, this thing start idx. Okay, so start idx. So here also there will be same, before removing check the frequency. If before removing the frequency is same, okay, if before removing the frequency is same, so what you will do, you will decrease the equal character. So frequency of start idx is equal to frequency sub of start idx. If before removing it is same, then equal count, because from equal we are going to unequal, so equal count will decrease. But suppose after adding it is becoming same, so after adding, if after removing it is becoming same, so we'll increase the equal count. So this is it that we have to do, and let us test this first. Okay, it is equal to. Okay, so it is frequency sub is s is small. Where exactly? Yes, s is small here as well. Yes, so it is accepted in samples. So yes, it is working fine and we are way ahead in terms of time and space. So if you look here, now this is the n loop, and inside this there is no 26 loop, like these are just O of 1 operations. So now the time complexity is nothing but n, and the space we are using 2 maps, so the space complexity for this is O of 26. So this is it basically for this question. So I have discussed 2 solutions, one is the optimized and one is the most optimized solution for this. So yes, that's it, and if you like the video, please subscribe and like the video. If you have any doubts, feel free to ask in the comment section, and follow the pages in the description like Instagram and LinkedIn. And yes, that's it for today, and see ya.